Okay, so we're going to be talking about the boundedness of a function. Boundedness is very closely related to local or absolute extrema, minimums and maximums. Specifically, we're going to be looking at absolute values, the ones where a graph has either an absolute highest point or an absolute lowest point, and we're going to be talking about how that ties into boundedness. There are 4 types of boundedness that a function can have. It's only going to have one of these, and you'll see why by the definitions in a little bit. A function can be bounded below, meaning it's got a lowest value possible. We'll talk about that in a minute. Bounded above, bounded, and unbounded. And we're going to look at an example as well as the definition of each of these. We're going to be looking at them for now from a graphical standpoint. Eventually, once we get into the parent functions and their transformations, then we'll be talking about them more as an analytical kind of process. Okay, so let's look at the first one. A function is bounded below if it has an absolute minimum. So I've got here the function y equals x squared plus 2, and we can see in its graph that it has an absolute minimum where y is 2, meaning it never goes below that point. That's what we call a function that is bounded below. It has a lowest value that the graph never goes below. Now when we say that, when we write it, we're going to write that it is bounded below, and then we're going to state the y value. Bounded below y equals 2. For that reason, 2 is the lower bound of this function. It's the lowest point on the graph. And that is bounded below. It has an absolute minimum that the graph never goes below. It is bounded below. Okay, so now let's talk about bounded above. A function is bounded above if it has an absolute maximum, meaning the graph will absolutely never go above that point. So we've got our function here, y equals the opposite of the absolute value of x plus 3. And we can see that the absolute maximum in this case happens right here where y is 3. Excuse me. So here we would write that it is bounded above y equals 3. Another way to state that is to say that 3 is the upper bound. Lower bound for absolute, or bounded below, and upper bound for bounded above. Okay, so bounded below, it never goes below that value. That's where the absolute min occurs. Bounded above never goes above that value. That's where we see an absolute maximum. So what does it mean for a function then to be bounded? A function is bounded if it has both an absolute minimum and an absolute maximum. We typically are going to be seeing this in our sine and cosine functions, where we can see that the behavior of the graph is trapped between 2 y values, and it never goes outside of those 2 y values. So here we've got our lowest and our highest values, and we can see that this occurs where y is 1, and that the maximum occurs where y is 3. So in this case, we would state that this particular function, that's a funky looking b, is bounded between y equals 1 and y equals 3. This function would just be said to be bounded. We don't call it bounded above and bounded below, just simply bounded. In this case, 1 is the lower bound, and 3 is the upper bound. And you can hopefully see how this is really related to the absolute extrema that we talked about previously. A point on the graph for which the graph never goes above for an upper bound or an absolute maximum, and a point on the graph for which the graph never goes below, which would be our lower bound or our absolute minimum. If a function does not have an absolute max or an absolute min, then we just say it is unbounded. Now, in most cases, that means you're going to have at least one of your limits is going to be, in behaviors, are going to be pointing toward infinity. So in this case, I can see there is no absolute minimum because this graph continues on down toward a negative infinity value. And likewise over here on the right, I can see that it's never going to have a bound because it's continually going up to a positive infinity value for y. Excuse me. So in this case, we would just simply say it is unbounded. Which means we don't have to worry about lower bound, we don't have to worry about upper bound. There's none of that to concern ourselves with. It's just simply unbounded. In your book, you'll find that it refers to bounded on its domain or unbounded on its domain. That just means that within the full range of values that x can take on, within that domain, we should see these behaviors: bounded above, bounded below, unbounded or bounded. And that's the 4 values. There are 4 different types that you can have. So as long as you understand entirely what absolute extrema are, then this should tie into that very easily.